Hi, I'm an old guy and I do maths, and today we're looking for the derivative of this little beauty here, this expression, x plus x squared plus 1 to the power of a half, all to the power of 2. And I guess the initial thing is to identify what we're going to need to do to solve this. We're going to need to use the chain rule. The giveaway is this outside this bracket, but there's also a chain rule problem within this, which makes this doubly interesting. Now, dealing with this this version of the chain rule, we can write the expression in here, u, as either this or this. It doesn't matter. It's sometimes easier to write it like this, sometimes easier to write it like this. Anyway, let's get going. So let's start with finding the derivative of this thing. Okay, so I'll spoil the surprise. This is the derivative. dy du is 1 plus x on the square root of x squared plus 1. And I've written it this way just for the sake of convenience. So, why is this so? Well, there's a bit of work that goes into this. So let's have a look at that, and I'll just talk you through all of this. So the derivative of x is 1. So that's not a great problem. What we're really looking for is the derivative of the second part of this, which is x squared plus 1 to the half, or the square root of x squared plus 1. Okay, now to find that, we need to use the chain rule. Now, as I said to you at the start, there's a chain rule problem within this. And at the moment, what we're looking for is we're looking for the derivative of this. We found the derivative of this, which is 1. We're looking for the derivative of this or the derivative of this. To find that derivative, we would normally write this like this. Okay, so back down to work here. Right, we use the chain rule. So u is x squared plus 1. The derivative of that is 2x. The derivative of u is a half u minus, a half u to the power of negative a half. I hope that that's understandable. The assumption is that if you're looking at this, you understand the chain rule. Okay, so let's get to work here. What we wind up doing is multiplying dy du by du dx. So here goes. This is the multiplication here. When we multiply all of this through, what we get is x on the square root of x squared plus 1. This is a negative square root, so it sits below the line, so to speak, as a denominator. 2x times a half is x, and that gives us that. Now, that is only part of the problem. Remember, we're differentiating this whole thing. And in order to do that, there's some more work to come, which I prepared earlier because it's sort of hard to do this and talk about it without making too many mistakes. So let's have a look at what we've got. We're looking to find the derivative of this expression here, and we're going to use the chain rule. So the chain rule states that dy dx is equal to dy du times du over dx. Right, what is dy du? Well, we spent the previous page finding it. There it is. What is dy dx? Well, it is, how can I'll write this here. No, actually I'll write it over here. Take one more look at that. We're going to derive that as if this is u. And what we get, so this is 2u to the power of 1. What we've done is we've treated this as u, which is what it is, but we've written in its actual value. And so it is 2 to the power of 2 minus 1, which equals 1. So let's put all that together. We can put the 1 in here just for the sake of completeness if you wish. It doesn't have to be there. So the chain rule says that dy dx is equal to dy du times du dx. You will be sick of hearing that, but it's important. So it tells us that we must multiply this by this to get the derivative of our original function, which, one further reminder, was this. Okay, so here is what it is. It is 2 into x plus the square root of x squared plus 1 to the power of 1, you can just ignore that, times 1 plus x over root x squared plus 1. That is the derivative of the function that we started out with. Now, I hope that you found it useful. This is an example of a chain rule problem within a chain rule problem, and it is not an uncommon occurrence. Anyway, if you did find this useful, please like and subscribe, and I'll see you next time. Bye.